Question 4. A megaphone uses a loudspeaker to amplify sounds that are detected by a microphone. Figure 10 shows a megaphone and microphone. It's the microphone and the megaphone. Question 4.1. Complete this sentence. The microphone is used to convert the pressure variations in sound waves into variations in current or potential difference. Potential difference is voltage. Question 4.2. The loudspeaker contains a permanent magnet. Which diagram in figure 11 shows the direction of the magnetic field between the north pole and the south pole of the magnet? The magnets are shown in cross section. We know that the magnetic field goes from north to south and north to south. So that seems to be correct. This is wrong. That is correct, but this is wrong. That is correct, and this is wrong. That is wrong, and that is wrong. So the answer will be this one. Question 4.3. Some magnets are permanent magnets, and some are induced magnets. What is an induced magnet? A material that becomes a magnet when it is placed in a magnetic field. Figure 12 shows the parts of the loudspeaker in the megaphone. A current in the coil of the loudspeaker causes the coil to move. Question 4.4. What is the name of the effect that causes the coil to move? Electromagnetic effect? No. Induction effect? No. Motor effect? Yes. Speaker effect? No. Question 4.5. When the current in the coil is 16 milliamps, the force on the coil is 0.013 newtons. The length of the wire that makes up the coil is 6.5 meters. Calculate the magnetic flux density around the coil in the electromagnet. We're given the current, which is 16 milliamps. Milli means 1/1000, which is 10 to the power minus 3. And therefore, we can get the current to be 0.016 amps. So I have to convert that from milliamps to amps. The force is given as 0.013 newtons, and the length L is 6.5 meters. Applying the force equation for the magnetic field, force in the magnetic field is B-I-L. I is the current, B is the magnetic flux density, L is the length. Therefore, we're looking for B. B equals to force over current times length. If we populate it with the values, we get the value for B to be 0.125 Tesla. So finally, magnetic flux density equals 0.125 Tesla. Question 4.6. Megaphones can produce very loud sounds. A person's hearing can be affected by age and by working in a loud environment. Figure 13 shows how frequency affects the minimum sound level that can be heard by 3 different people, A, B, and C. Compare how different factors affect the minimum sound level that these people can hear. For all 3 people, the minimum sound level that can be heard increases as frequency increases. The minimum sound level that can be heard increases with age. In between 2000 and 3000 Hertz, the minimum sound level that can be heard increase more in B compared to C. C has a very little variation in the minimum sound level that can be heard at all frequencies. Working in a loud environment increases the minimum sound level that can be heard at all frequencies above 2000 Hertz compared to working in a quiet environment. The minimum sound level that can be heard increases more as frequency increases from 2000 to 4000 Hertz compared to working in a quiet environment. Finally, does not affect the minimum sound level that can be heard at 2000 Hertz.